Welcome to my science tutorial. In this video, I want us to look at Boyle's law. Now, when we mention Boyle's law, what comes into your mind is the gas laws. Boyle's law is one of the gas laws. Now, talking about gases, there are four factors or four things that determine the properties or behavior of gases. And these four things include number one, the mole of the gas. Number two, we can mention temperature. Number three, we can talk about volume. Number four, we'll talk about pressure. These are the four things that basically controls the behavior of gases. So think about a balloon containing some mole of gases. If this is the balloon and it contains some gases, what happens if the temperature goes up? When the temperature goes up, the molecules or the amount of gases you have here, talking about the mole of the gas. Now, all these gases particles will get kinetic energy, they will increase in kinetic energy and push against the walls of the balloon. And so the balloon will expand, and they will say that the volume will increase. The volume will increase. And the fact that these gases are pushing against the walls of the balloon will say that the pressure is exerting pressure on the walls of the balloon, and so the pressure is also increasing. Okay, so these four things actually controls the behavior of gases. Now, what is Boyle's law? Boyle's law states that for a fixed mass of a gas, so we talk about fixed mass, and we are talking about mass, then we are talking about mole, because mole is directly proportional to the mass, okay, and inversely proportional to the molar mass. So we are talking about fixed mole of a gas at a constant temperature. That means the temperature T is not changing and the volume is inversely proportional. The volume is inversely proportional to the pressure. So that means it's going to be inversely proportional to the pressure. That is when we are considering a fixed mass of a gas at constant temperature. That is what happens. So now let's put this in a mathematical expression. Again, let's read the law. It states that for a fixed mass of a gas at constant temperature, the volume is inversely proportional to its pressure. So inversely proportional to the pressure of the gas. So what happens if we introduce a constant proportionality? And so we'll have K, which is going to be our constant, and P, the pressure. So we'll have V equals K over P, which is pressure. That means that we can say that K is equal to Vp when we multiply through by pressure. This will cancel this, so K is equal to Vp. We must as well call this one equation 1. Okay, so from Boyle's law, we are saying that the product of the volume of a gas and its pressure will give us a constant. So when we are considering two separate conditions under fixed moles and fixed temperature, then we'll say that the product of the volume and the pressure will always be the same. That is what it means. Now let's look at this. Now this is a container, and this is a piston. This is a piston. This container B, the same container, but different scenario B. Now what is happening here? When we push down this piston, down, that means that we are increasing the pressure. And simultaneously the volume will also be decreasing. decreasing volume. That is what is happening in A. We are we are pushing down this piston, but when it comes to B, so as a result of A, we have this. You can see that over here the particles are quite far from each other, but over here they are closer to each other, and so the volume has decreased. The volume of the gas here has decreased because we have pushed down the piston. Now when we come to B, what if we pull up the piston? What if we pull up the piston? You observe that the pressure will be decreasing, and simultaneously the volume will be increasing. Volume will be increasing. So that is what actually happens when we are talking about Boyle's law. So let's say in this situation here in V and in A, and the volume is, let's say the volume is 10, let's say 10 cm3 or 10 dm3, and then the pressure here is 1 atm. Let's say that's the pressure that is being applied, and then over here we have, as a result of the pressure being applied, the volume will what decrease. So let's say the volume here is has decreased to 5 dm cube, and then the pressure, because the volume has decreased, that means the pressure has increased. So we say the pressure becomes 2. And remember, we said that the mole, we are talking about fixed mass. So it's the same as saying a fixed mole. So we say that temperature is constant. It's not changing. And the same thing with the mole. It's also constant. It's not changing. Okay. All right. So when we consider Boyle's law, we say that K is equal to Vp, and the V here is 10, and the pressure is 1. So we'll say that K is equal to 10. Now when we come here, we have volume. So let's say this is V1 P1, this is V2 P2, and the same constant Vp. But over here, volume is 5, so we'll have 5 multiplying pressure, which is 2, and this will give us 10. So we observe that when we have P1 V1 multiplying, it gives us a constant of 10. When we have P2 V2 multiplying, it gives us a constant of 10. And so we can conclude that P1 V1 is equal to P2 V2. So guys, that is Boyle's law. That is what Boyle's law is about. So in your exam, okay, before then, let's talk about the graphical representations. Now, talking about the graphical representation, remember we said that P1 V1 will be equal to P2 V2. So let's say we have a graph like this. When we have a particular volume, say particular volume V1, let this be volume, and this pressure, particular volume V1 over here, and then we have a particular pressure P1. So let this be a P1. Now, we say that when we decrease the volume, the pressure will also increase. So let's say the volume has decreased to V2 over here. The pressure will also increase. So we'll call this our P2. Remember, this is P1. So what happened if you draw a curve? We'll end up having a curve like this, and then when we calculate for the tangent, we'll have the gradient. We calculate for the gradient, we'll get k. So we'll get k. So this is how the graph of Boyle's law looks like. This is how it looks like. What if we plot other things like P against the inverse of volume? If you have P, pressure, against the inverse of volume, 1 over V, you end up having a straight line where this will give us the constant. The same way if you plot volume against the inverse of pressure, and this volume will have the same thing, a straight line, and this will be our K. What if we plot the products of pressure and volume against pressure? So let's say we are plotting this. This is PV, and this is pressure. We end up having a straight line. Okay, so guys, this is how the graph of Boyle's law looks like. This is the actual graph, and all these are altering when we take the inverse of the volume, the inverse of pressure, the products of pressure and volume. These are the graphical representation. So in your exam, if I give you a question like this particular one says a sample of air occupies 3.8 dm cube when the pressure is 1.2 atm. Okay, so the volume there is 3.8 dm cube, and then the pressure P is 1.2 atm. So what is I saying? I says what volume will it occupy at 6.6 atm? 6.6 atm. Now how do we go about this? We will have to use our expression P1 V1 equals P2 V2. Okay, now we are looking for a new volume at a new pressure. So what we are actually looking for is V2. Now when we make V2 the subject, we have P1 V1 divided by P2. So V2 will be equal to 1.2 times the volume V1, which is 3.8, and then we divide through by the P2, which is 6.6. 6.6. When we punch this, we are going to have 0.69 dm cube. Now the second part says that calculate the pressure required to compress the gas to 0.075 dm cube at constant temperature. Constant temperature. All right. So what we are looking for now is the pressure. So pressure P2 will be equal to P1 V1 divided by V2. Okay, so P2 is going to be equal to 1.2 times 3.8, and all of this divided by the new volume, the volume 0.075. Okay, so let's put this in a calculator. We'll have 60.8 atm. So guys, this is how the questions will look like when you are given a question pertaining to Boyle's law. I hope you like this video. Don't forget to subscribe to the channel. Thank you.